All right, thank you. So before you, what is given is an output or the summary output that you get from Excel. The data has already been encoded into Excel, sorry, and then the data has been regressed. And after regressed, then there is the output that comes out. So the assumption that we are making now is that you already know what is happening behind the back doors. That is to say, you know what the computer goes through so that it can come up with these numbers. So what happens is that you command a computer in a certain way so that you can have this output, okay? So all these things that you are seeing here are just basically the figures that you get from the computer. They are given. For the sake of your exams, usually this output, since you are not going to be, first of all, are your exams going to be physical online?
Physical.
Oh, okay.
Has class started? Hello?
Yes, madam.
Hello.
Has class started? It looks like it's just freezed. So I'm asking, saying hello.
Oh, sorry, the mic was off. I kept on talking to self. Guys, people are not okay. Can you hear me now?
Yes. Yes.
Oh, okay. Yeah, sorry. I kept on talking, guys, the mic had gone. So I was just saying that this what you are seeing right on the screen is just the output that you get from the computer. And you have said that your exams will be physical, which means that you will not go with computers in your exam, which means that if they want to ask you questions around this, they can print out the output already. Okay, like the way how it is already printed out. You've seen that there is a summary statistics from Excel. It has been printed out. Then there are questions down. Okay, so it can be printed out. Then you are just asked to answer some questions. Okay, so actually, what usually happens is that the way how you are supposed to learn it, but you can still learn this way. You are supposed to learn first physically how this output, like how you come up with this output. What I mean is that you start by calculating, for example, how do they get these figures? Yeah, how do you get those figures? Before the computer helps you, I mean, like you doing in the hands, okay, like doing in the hands. So what is there is that the work of doing with the hand is really a lot of work, but since they have already produced the output and what is required of you doing, I've seen and I've checked from your module, is just to interpret. So most of the knowledge that you need is just to interpret the output. Okay, how do you interpret these figures? So we'll just focus on how to interpret these figures that you're seeing. You get to understand what they mean, what each figure means, and what it tells you as a statistician when you are researching. That's all what is actually there. So what is there is as we said last time under hypothesis testing, you are dealing with data, okay? You collect the data. After collecting that data, you want to use that data so that you can come up with some information, okay, or make some inferences, some conclusions. So what you do with the data is that you're going to organize the data in a certain way and investigate from the data. When you do the investigations, you're going to come up with some figures. Now, these are some of the figures that you come up with. Okay. Once you come up with those figures, then you should be able to interpret those figures so that you get what you want. And you interpret the figures and you come up with information, then you make the decision. So that's what is there. So in short, what I'm trying to say is that actually you are not really just supposed to start from here, but since your exam will require you just to have this knowledge, we'll just start from here. Since we don't have a lot of time to go back to start teaching you how you calculate these things with the hands, yeah, the time is not just there. So you can still understand, I know. Just focus and concentrate on what you're going to do today, then you will still understand. So the idea of regression analysis is to find out if you, for example, you select. Let me create some hypothetical example. No, there is no need of creating one. The example is already here. There is this example that we are given. We are told that a human resource consultant conducted a study on the determinants of the beginning salary of employees at a local parastatal. The results of the study are presented below. Okay, so this one was is the HR consultant. Okay, he has done a study about trying to investigate the determinants of beginning salary of employees at a local parastatal. Yeah, you just want to ask what really determines, okay, the beginning salary or the salary to start with. So we are looking at the determinants. So it's like the statistician went out, or the researcher went out to find out some of the factors. When he found out some of the factors, he looked at things like, does gender of employees matter? Okay, or does that influence? Those were the questions. So he collected data about gender employees. Does the age of employee matter in determining the salary? Does the job category matter? Does the education level? Okay, I'm sure are you able to see but what I'm trying to show you here? Hello?
Yes, sir, we are.
Okay, yeah. So these are the determinants that he sampled. So he wanted to investigate, do these things really matter? Okay, you got the gender, you got to consider the gender of employees, the age of employees, the job category the education levels in years, and the work experience. So these are some of the things that the researcher chose. Okay, these are some of the factors that the researcher chose to use. So now these things that he chose, we are calling them as the independent independent variables. Okay, they are called independent variables. The independent variables, those are influencing variables. They are influencing a certain variable. And what is the variable that they are influencing? Is the beginning salary. Okay, we are investigating what determines what is influencing the beginning salary. So the beginning salary, or let me just write it as PS. The beginning salary, that's what is being influenced. Okay, so when you are researching, most of the times the variable that you are influencing, it will be called your y what? Your y variable. Your y variable is always called the dependent variable. Okay, it's the dependent variable. The dependent variable is y variable. The dependent variable is influenced by the independent variable. Okay, those factors that are trying to influence that thing. Yeah, just follow nicely. I know it might be sounding maybe some complicated, but I want you to follow clearly. You get it. Then there are some of the other names that you really need to pay attention and you need to understand on the independent and dependent variables. The dependent variables, these are influenced variables, okay? They can still be called the explained variables. Explained what? Explained variables. So explained variables, that is referring to the dependent variable or the y variable, the variable that you're trying to investigate, like that is being determined by some factor. So then the variables that explain that variable are called explanatory variables. Okay, they are called explanatory variables. Okay, yeah. Explanatory variable and independent variable is the same thing. Those are just other names, like the synonyms. So you can call them independent variables or explanatory what? Explanatory variable. You can call them the y variable or x variable. The x variable are the independent variables, okay? The independent variables are usually along the x-axis, so they are x variables, whereas the dependent variables usually along the y-axis, they are called the y variables. The explained variables are same as the dependent variables. Explanatory variable, that is the independent variables, okay? Use this, you can say outcome variable, okay? For if you don't want to use the dependent variable. The dependent variable is also called the outcome variable. The outcome variable is determined, if you want to use outcome variable, then the x variables will be called the covariate variables. The covariate variables. If you want to use outcome.
Now,
okay.
which is there, 100%. The other one, we are using the phone for the support.
Oh, okay. All right, let's follow. But if you want to, sometimes you can also call the y variables, the variable that is being influenced as the response variable, okay? The response variable. The response variable is called the response variable because it's responding to some changes. The changes have been caused by the what? By some other variable or the independent variables, right? So in that case, if you call your y response variable, then your x variable should be called, or the independent variable, which is the influencing variable, you should call it the stimulus, okay? You should call it the stimulus. So basically, these are the same things. So what is there? What should we take now? What is the take home? The take home is this one. If you call stimulus, then you should use the response, okay? A stimulus variable, if you want to use a stimulus variable to mean the independent variables, then use the response variable, okay? Then if you want to use you want to call the y variable the dependent variable, then the x variables or the influencing variable, the variables that influence that variable, you should call them as the independent variables. Then if you want to call y explained variable, then the x variables should be called what? Explanatory variables. Then if you want to call your y outcome variable, then your x variables should be called what? Your covariate variables, okay? Your covariate variables. So basically, those are just some of the synonyms that you use, some of the words. So what we are trying to say is that there are some factors that are trying to influence a certain variable. That variable which is being influenced, it is called a dependent variable. Then those factors that influence the variable are called independent variables. Clear? I'm just on the terms. I'm still introducing you to the terms. Is that clear? Or any question? Hello?
Yes, sir. So I have a question. So in
Yes,
an
yes, madam.
in an exam setup, there are times when maybe they use response, so we have to figure out that automatically a stimulus variable is involved.
Yes.
Okay.
Yeah. So what we're trying to say is that they can maybe tell you that they guide you that whereas the stimulus or the stimulus variables are given as these. Then the response variable is this one. You don't need to get confused about what stimulus. You get it, So I introduce you to these terms just to know how they are used and what they really mean. They just mean the same thing. In this context, we use them like that. Clear?
Yes, sir. Thank you.
Okay. We have known the language that we actually use. So we are just trying to examine these factors and what really they do and how they influence. So really, I've done it. This is more like a jump starter, but you will understand. That's what you are required of doing. Yeah. So what is happening is that this is statistician now or a researcher collected data, just as we showed you last time now, collected data about the gender. Maybe he was using, let's say, a questionnaire. You collect data using a questionnaire where you go, you ask people about what's the gender, are you male or female? They write, what's your age? They write those employees just to find out from this parastatal. What's the job category? They find out, they write down. What is your education level? They find out. What is your work experience? You get, they found out from many people, okay? After finding out from many people now, you want to get that data and examine which one is really significant, okay? We're talking about the factors, those factors. Which one is really influencing the what? The influenced variable. Which one is determining the determining variable? I think you are following. You're following what we are trying to do. So this is what the researcher did, collected data, okay? And after collecting the data physically, you enter that data in Excel, okay? Yeah, I'm showing you where these figures came from. Yeah, where these figures came from. Really, it's a lot of work to come up with these figures. That's why it's usually done under research when you're researching. So after you collect that data, you feed the data into Excel. Then from Excel, you command Excel, you do data analysis. We'll do those things. You're still having some good, these years, we'll still be meeting. I mean, maybe next year. Is it next year? That should be, when are you becoming second years? Is it this year? October or November?
Yeah, this year.
Should be October, somewhere in November. Yeah, you second years. Yeah. So very soon you reach at this level where we'll be looking at these things like in detail. So what will happen is that you feed that information into Excel. You command Excel under like you go where it says data analysis. You command it, will show you how to command. Then Excel, the computer will give you this on the screen as the output, this page that you are seeing, okay? This page will be printed out because yeah. So Excel has analyzed that data. It has helped you to analyze that data. Then it has given you this as the output. Then what you are required of doing, like in this exam, is that this one is printed out, is given to you, these figures. Then now, as a researcher, what does it tell you? Okay, when you see these numbers, what do you understand? When you see these letters, what do you get? Okay, what's your conclusion? Yeah, so that's what we are trying to talk about this evening. So number one, let me explain the variables, what they mean, and how to interpret them. Then we'll do these questions that are down. Then I'll also give other questions. We'll get other questions, but at least you've gotten the background of what you're trying to say. Let's start from which one is which? From multiple error. Let's start from error. Let's start from multiple error. Usually this one is labeled as multiple error. Okay, this error that you are seeing as multiple on Excel as multiple error. Multiple error from the model summary. Now, what does multiple error and what does it tell you? Listen, this one you've seen, this is 0.85, okay? It's 0.850. So when you multiply by 100, this is equal to 85 what? 85 is approximately 85%. Okay, now what is multiple error in statistics? Like when you're doing it, it simply means correlation coefficient, okay? Correlation coefficient. Correlation coefficient, that's multiple error. Correlation coefficient, multiple error. Now, what does the correlation coefficient tell us? What does this number tell us? Okay, correlation coefficient measures the linear relationship, or examines the linear relationship that is there between the variables that you are trying to do to analyze. Okay, that is the linear relationship that is there between the y variables and the what and the x variables. Okay, we want to check how they are linearly related to each other. That's what we are trying to examine, and that's what this correlation coefficient brings about. So you are examining the relationship, the measure of the association. How related are these variables? I don't know if you've gotten that one. So we are measuring the relationship. Are these variables related? We mean the variables like x and y, the dependent variable, the dependent variable, and what? And the independent variables. In short, we are trying to, what is our dependent variable? It's the beginning salary, right? They have guided here. They have said the dependent variable is beginning what? Salary. So the beginning salary, that's our dependent variable. So our question is, the question is, how related are these factors, okay? The beginning salary and these independent variables. The independent variables that we have are gender of employees, age of employee, job category, education levels, okay, work experience. So we are trying to examine how related, okay, are these variables to y, to the beginning of salary. So that's what this multiple error measures. So now listen, the closer this multiple error is to 1, then it means that that's how strong the relationship is, okay? The closer it is from 1, the variable or the coefficient will always be from 1 up to, that's from 0 up to 1, or from 0% up to 100 what? 100%, okay? So the value always fall in between here. So what it means is that the closer it is, the number is to 100, then the stronger the relationship that is there between the y and the x variables. Okay, so I've seen like the one that we had, this one we have is 0. What? We had 0.85, right? This is 85%. It's closer to 1, okay? It's above 0.5, it's closer to 1. So that means that there is a strong relationship on average between these x variables and the dependent variable y. Between the x variables, the independent variables, and the dependent variable, there is a strong relationship. Okay, but if you find that you find a number like the multiple R, you just find maybe 0.2, okay, 0.20. This is 20%. This is a weak relationship. It's closer to 0. Okay, so it means that the relationship between the X variables and the Y variables. I'm sure you're understanding what I mean now by X variables and Y variables. X variables are independent variables. Y variables are dependent variable. There is the dependent variable that you're trying to determine. So if you find that the number is closer to 0, it means that the relationship is very weak. Okay, there is a weak relationship between these between the two. Then what if you find 0? Okay, if you find that the answer is 0, it simply means that there is no what there is no relationship. Okay, there is no relationship between the Y variable and the X variable. I'll write down. If you find 0 as your multiple R, it means that there is no relationship between X and Y. That means that the dependent variable and the independent variables are not related linear. Okay, there is no linear relationship. But if you find the number that is closer to 1 to 0, it means that there is a weak relationship. The number that is closer to to 1, there is a strong strong relationship. Okay, so the number the closer the number gets to 1 or to 100, it simply means that the more stronger the relationship gets to be between the two variables under concern. What if you find a negative? Okay, a negative simply means there is a negative relationship between those variables. Okay, negative relationship. But if you find a positive, it means there is a positive relationship. But about the strength, listen. About the strength is about how close is it to 1 or to 0. So that is to say, you can still have this direction to negative, like let me say from -1 to 1. So if you find that it is maybe your answer is -0.20, right? It means that there is a weaker negative relationship. Okay, there is a weaker negative relationship between the X and the Y variables. But if this number is getting closer maybe to -85, it's closer to 1, it means there is a strong negative relationship between X and Y. Do I have a question on how to explain what multiple R means? Hello? Can we move to the next variable?
Yes, sir.
Okay. If you've gotten what multiple R means, then I'm okay. I'm happy with that. Then we can move to the other variable and check. Let's examine the other element, what they mean. We just want to interpret what they mean, then so that when you answer questions, you are understanding down what it means. Let's go to R squared. R squared, okay? R squared is written like this in your notes. If you check in your notes, it's written like this. But it's only this is the computer. It has written like that. The computer will summarize like this on Excel. But when you go in the notes like physical, when you're solving with the hand, it will be written as R squared. R squared is called the coefficient of determination. Coefficient of determination. That is the name, right? In the notes. That's what it means, but Excel summarizes just as R squared. Okay, R squared is the coefficient of determination. In this case, this is 0.722. Okay, that's what we've gotten. Like this is what is labeled here. What does it mean? Because we are interested in the meaning here. What you focus on is interpreting. the interpretation. Zero. What does error squared mean, or what does it measure? The coefficient of determination. This one measures the percentage, okay? The percentage of y, that is the percentage of variations in y, variations in y, explained by what? Explained by the model, or explained by x variables. Did you get that? That's what it measures. So it measures the percentage of variations in y explained by x variables. That is to say, we are trying to examining the percentage of changes that take place in the dependent variable. You know that y means a dependent variable. In the dependent variable, in our context, you're talking about the beginning salary, right? That's our y variable. So we are examining the variations, the percentage of variations or the changes in the y that are fully explained, or that are as a result of the x variables that we have. These variables that we have listed, like gender of the employee. Is it because somebody is a male or female? That's what determines their salary. Is it because of their age, the job category? Is it because of the education level in years? Is it because of the work experience that they have? Okay, so those are x variables. So in short, when you look at R squared, we are trying to examine how much of those changes in y, the variations, are really explained by x, or in short, how much of the x variables account for the changes in what? In y. Did you get that?
Sorry, sir, can you say that again?
Yes, I'm saying that the coefficient of determination examines the percentage of variations in a dependent variable that are explained by independent variables, the given independent variables. That's what it means. Or that's what it measures. So in our context, we have been given that the coefficient of determination is what? Is 0.72. 0.72. When you multiply this by 100, it's around 72, right? This is 72%. Okay. What this means, it means 72% of variations in a dependent variable. What is our dependent variable? It's the beginning salary. Yeah, that's our dependent variable. That's what we say. So 72% of the changes in the beginning salary are explained by, number one, the gender of the employees, the age of the employees, the job category, the education level in years, and the work experience in months. Did you get that?
Travis.
Yes, sir.
Okay.
Okay. Yeah, that's what this tries to measure. Actually, that's what it measures. So R squared, it measures the percentage, how much of that. So listen now. If you don't want to write like this, you can write it measures the best of fit. Okay, the best of fit. But what that means is that it tries to examine how fitted the regression line is between the variables, how it is fitted. Okay, so how good, the goodness of fit, how good is the what is the model. Okay, tries to examine how good the model is in trying to explain the variables that you're trying to regress or analyze. So what it means is that if you find, listen now, if you find that your R squared, your coefficient of determination, or R squared, is something that is less than 50, what does it mean? Less than 50, maybe you find 0.42, or which is 42%. This model is not a very good model. It's a bad model. It's not a dependable model. It means that these variables that you have chosen as the the influencing variables, their impact is not really a lot, actually, to what you're trying to examine, okay? They are not so significant to say. It means that these variables, they are explanatory variables, right? They try to explain. So it means they just try to explain only 42% of the variations in Y, which means a huge percent, approximately 62%, is not what? Is not explained, hence captured in the stochastic variable. And if you find that only 42 is explained, the larger section of of the variations is captured in the stochastic variable, the error variable, then the model is not a good fit. You can't use that as a researcher. Otherwise, you won't graduate, like you can't. I mean, as you are writing your research, you write your research at 4th year, you'll be writing your researches when you come for the postgraduate, just like that. So you can't do that. So your model, like your fellow scholars or like your supervisors, will not agree with you. They will not allow you to continue. They won't allow you that you can graduate when you research a research. But the model that you have used when you're trying to investigate that question you're trying to study, it just gives you only 42, which means that those variables that you chose to explain that particular phenomenon or that particular thing, they don't really explain as they should. They just explain only 40%, meaning the largest section thereof remains unexplained, and it is usually captured in the error variable. So it's not a good model, and you can't go and research. Then you can't come up with a decision if you have not, if your model, when you look at your model, is not dependable. Even if you come in, you say, you postulate now, you pose that proposition, you say, no, according to what I researched, I discovered that, for example, the gender of employees influences what? The beginning salary. But when you look at the model that you used, if the model is not dependable, we will say, no. But first we'll have to look at the model, the way how you are doing it. Yeah. And those are conversations you hold in research. Did you get that? You can ask.
Yes, sir.
Yes. So in short, this number is supposed to be closer to what? To 100. To 100. It can't be 100%, of course, again, because of the errors again. They can still be errors. But at least it should be able to explain maybe above 80%. It's a good model. Or maybe 7. At least it shouldn't be less to way less. Because this one it implies that only what? 28% is not captured. Yeah, it's not explained. The other, it just explains 72%, then 28 is not explained of those changes. Hello, am I making things complicated? I don't know. Or I'm simplifying. Yeah. Hello.
Hello, sir.
Yes. Are you following?
Yes, we are.
Okay, that's a good thing. I want to comment much on the adjusted R squared. Yeah, but I'll just 2 things. It's not within your scope. It's only that Excel will just give you everything, even what you don't need, depending on whatever. Yeah, it's not really within the scope, but what adjusted R squared means now is this. When you are researching as a researcher, or when you're conducting your research at whatever level, either bachelor's or upwards, is that when you add the variable, like these independent variables, to your model, what happens is that this R squared, the coefficient of determination will increase, regardless of the impact or the statistic significance of the variable that you have. Okay, it will increase. It has got that tendency of increasing. Whether the variable that you have added has got impact to what you are determining or not, the R squared will increase. So ultimately, we have said we need a good R squared, a big R squared, right? The one that's closer to 100. So what will happen is that the more variables that you have, maybe you have 12 variables, you find that your R squared is closer to 1, but it's closer to 100. Maybe it's 90 something, 80 something. But really, that is not dependable. You get, you cannot really just fully depend on R squared. This just R squared, because it has got those weaknesses. What R squared does actually, it increases now as you add these variables. As you increase, if you added another one, how many are they? We have gender, age, job category, education, and what that work experience. There are 5, right? These are 5. If you added the 2 more, you find that the R squared will increase, maybe to somewhere 78. Okay, which means there are more factors that you have considered that they try to influence that thing. But the problem is this now. That may not be the truth, because those variables that you are adding, some of the variables might not have the influence. You get it? They might not even be influencing the influenced variable, the dependent variable. So therefore, that's why the need of adjusted what? R squared. Excel gives you adjusted R squared. Similarly, even when you're using other statistical packages such as the Stata, others pronounce it as Stata, but this is Stata. From Stata, you have other statistical views such as eViews, Excel. They give you the adjusted R squared. When they give you the adjusted R squared, what they mean is that they have factored in or adjusted this R squared for those variations that I'm trying to say. Because what will happen with the R squared, once you start removing those variables one by one, you start seeing that it will be decreasing, and decreasing. So you find that there are some variables that might not even be significant, okay? So the adjusted R squared will try to take into account that. So the adjusted R squared is a good one. But most of the times at this level where you are just asking most of the questions under R squared, because the adjusted R squared also deals with the comparison of the models. You are dealing with the other models. You're also trying to compare other models. So that's when you use the adjusted R squared. So in the meantime, that's what I can just say about that. I want to comment about the standard error in the meantime, or at this stage. Let me not comment on that. I may just waste much time. Let's move on to, which one is this? The Anova. Now, what do the initials Anova stand for? These are just initials. Anybody? Hello. What did we learn from the prof? What did the prof say Anova means? Okay, Anova is analysis of variations. Analysis of variation table gives it gives you this now. So listen now to the way what this means. Quickly, I'll just explain some of the key things here. I want to explain everything. Really, it can take us a lot of time. Some of the things you don't even need them right now. Let me just explain some key things that you need. Let me start with this one. Okay. What does the regression sum of squares is called the RSS. Usually they cut it as RSS. You have the regression sum of squares. Then this one is the residual sum of squares, which is also called the error sum of squares, like estimated errors, then plus when you add the two, you should get the total sum of squares actually. Then the ESS, it should give you TSS, the total sum of squares. Yeah. So what you'll understand is that When you divide most of the times, RSS divided by what? By TSS, it gives you the R squared. Like it should give you the R squared. It should give you something like close to the R squared. Yeah, it's one of the ways of calculating that. Yeah. So, but not very much of the things should be, yeah, talked about. What is important here? Okay. Let me move to the coefficients. Let me just move to the coefficients. Oh, okay, now get the coefficients. The linear regression model. Now you pay attention here. We are coming closer to the questions. The linear regression model is given by y, the dependent variable. It's the red marker. Y, the dependent variable. Beta naught, that's the constant, plus beta 1, x variable, that's the independent variable 1. Then plus, depending on the number of dependent variable, y, beta 2, these are coefficients, okay? Beta 2 times x2 plus what? Plus maybe beta 3 if you have another what? Another independent variable. So these numbers of the beta, these, the 1, 2, they are just dependent on how many what independent variables you have, right? Like each beta is representing a coefficient of a certain what independent variable. So what I said is that, remember when you collect data, you go, you find out, you collect this data from wherever you're collecting it, or using whatever method of data collection that we are going, we'll also talk about those conversations, I'm sure, soon. What will happen is that when you look at this data that you get, when you calculate, either physically with your hands or with your calculator or with Excel like this with a computer, those numbers, they'll have the average, okay, the coefficient, that we call it the beta, okay, the coefficient. We could have shown you how the computer does it to come up with. These are the coefficients. The computer has already done the coefficients for you. Yeah, but you don't panic like for the purposes of your exam, since you were not given how to investigate how does the computer come up with that. You are just given to interpret. That's the focus. So yeah, let's just focus on interpreting. Certain way how the computer does it, but you can still do it with your hands. Though it's a lot of work, and with the calculator, that can still take a lot of time. Yeah, that's why these things are done during research, where you have a lot of time like given to you. Actually, you have given months and months. So what is there is, there are those numbers, those which you call the beta xi. These are coefficients of those different specific independent variable. There is this beta naught, which is the constant of that variable. It has got that constant. It has got that constant. Okay. How can I make you understand? Okay. Let me deliver like this. If you remembered very well, there was that mathematics you were learning about coordinate geometry in somewhere high school, where you were learning about y is equal to, maybe let's say the constant here. There was a constant number here. Let's call it beta 0 plus another number here. Let's call it beta 1 xi. So we put numbers, checking. This is y variable, the number that you are determining. Okay. Y shall be equal to beta naught. Let's say it's a constant number. This one, let's say it's maybe 50. Okay, 50 plus beta naught. That's the coefficient of that number when it was regressed during data analysis. Maybe it gave about let's say what number? Let's say just 5 maybe. Though it can't reach that far. 5x. Okay. Now listen. When we say x is influencing y, when you say x is influencing y, it means that if this x changes, even this variable will change. You know, this is mathematics, right? If this x change here, even this y will change. Take, for example, observe what is happening. if we change the, let's say x is 10, right? Let's start from 10. So have 50 plus 5 times what? Times 10, isn't it? That should give you y. Your y is 100. Okay, your y is it? Yeah, your y is 100. Let's change now x to what? Whatever number, let's say 5. You've seen, okay? We change x to 5. What will happen to y as well, which is the dependent variable? It will change to 75, right? 50 plus 5 times 5 is 25. It has changed to 75, okay? So in short, this y variable is moving as a result of the change in what? In this x, which is the independent variable. So now, what the message that we are speaking to you is that there is this constant number here that is never, whether that never depends on x, okay? It's constant. Whether x changes or not, like that output is more like whether these variables change or not, you still have that particular variable. Yeah. Hope you have gotten something from that. So these are the coefficients now. Let's start looking at them before we can interpret what they mean. So we have these coefficients. There are how many? Depending on the number of variables that we have: 1, 2, age of employees, education, work experience, job category, and gender of employees. These are betas. We call them these like the coefficients. Let's call them the betas. Okay. So our model will be like this, because you'll be asked to do questions. Maybe that question should be there. It is even here. I've even gone there. We are answering question number A, which says state the coefficient of determination, or state the coefficient of determination and interpret its value. Okay. No, before we come to that one, let's answer the coefficients. That's not coefficient of determination. What is the coefficient for age of employees? Anybody? Let's start with the constant. The constant is negative 1,691, right? 0.16 plus. What is this is your beta note, okay? Your 0, like 1. What is the coefficient of age of employees? Anybody?
The constant is 0.1.
Okay. So the what is the coefficient of the age of employees? What coefficient? These are coefficients like that you're given. So which one corresponds to the age of employees?
46.933.
Okay, yeah. So this is 46.993. Then you can put x what? X1, for example. This x1 is referring to the independent variable. The independent variable under concern is what? Age of employee. Okay. Let's call x1 age of employees. Then we will say plus. We are trying to come up with the model. I want you to see the model. Plus what? Plus the next variable, let's call it beta 2. We know that the next variable is beta 2. What is our beta 2? Our beta 2, let's choose the variable. Let's say education levels. Right? What is the coefficient? That will be your beta 2 now, like your coefficient for that variable. Hello? What's your beta 2?
353.
Okay, so 305 3.
0.379.
Let's round it off to decimal. 0.38. We'll call this as x what? X2 plus what is the next variable? Work experience. Or this one is a negative one, right? It is negative what? Negative 17.14 x what? X3, right? Plus, this is one model, plus, this is multiple regression anyways. Plus one, plus what? Job category. What's the coefficient? 12.7697, right? 0.97 x4, right? Plus, what's the next one? The last one is, is negative, this one. Gender, the coefficient for gender. So minus what? 1114.16 x what? X5. You have seen that, right? Then plus, okay, plus the stochastic variable. Just put this letter. It's more like E. It's not really E. It's a Greek letter epsilon. Okay, it's a Greek letter epsilon. 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 Yeah. So that's E. You just put this more like E, but it's not really E. Okay. What does this symbol mean? This one, it is representing the stochastic variable. Okay. The error term. In other words, it is called the error term. Right? Now, you remember the errors that I talked about when you are regressing, when you're examining these relationships. There are those errors, right, in the model. Those errors that are not explained by X variables, they are captured in the stochastic variable, this value, the error term. So that percentage is captured here. So remember when I was talking about coefficient of determination, Ri, I said if it, for example, it is 85, it means 15% thereof is not explained. That part which is not explained is captured by the error term. Yeah, so it's captured in here, in this symbol. So now, this is your what? Your model. Okay, this is your model. You can write it straight. It's only that I'm doing for the sake of this, for the sake of the screen that I have. Yeah, you can write it as a straight. It's a straight model. It's a long model. You've seen it, right? So what you would have to do is to give a key. Okay, on top, you have to give a key. And what is your key? You can name that. Your key means that B naught means the constant, isn't it? B naught refers to constant. X1 means what? X1 is equal to age of employees. You get that, right? You define this variable because you have just used the symbols now. Define what the symbols mean. So, yeah, X1 means what? Age of employees. B2 means age of, education levels. Work experience is B3. B4 is at B4, X4 is job category, and X5 is the gender of what? Employees. So X5, that's the what's that? The independent variable, which is the gender of employees. And the B5 itself is the coefficient of that particular variable. So this is the model that you have, okay, to use. So you will find that now, if you adjust and change, for example, X1, our X1 is what? The age of employees, right? If you adjust the age, maybe from 5, you just change this X1 here. If you will be changing this X1, for example, the age of employees, even this Y here will be changing, which is, what is your Y? What is our Y this time around? What did you say our Y is? Anybody?
The basic
Beginning
salary.
salary.
Yeah, the beginning salary will be changing, okay? As long as we change here, we increase it by 5, it will be increasing even this side. It will be changing just like that. So that will happen to all these other variables, whether you change the education levels or to beta 2 here, X2. Once you change here, you put a number, maybe 7, it will multiply with this coefficient. So you see that the whole model will be what? The outcome will be changing and changing. The salary will be increasing or reducing, depending on the impact of that variable okay, depending on the impact of that variable to the what? To the model. You really need to pay attention to interpretation, I repeat. So I'm saying that understand, get the gist around the interpretations of these numbers. Let them speak something to you, get something as a researcher or statistician. Hello, any question? We are good to go? Are we good to go? If you have a question, you can just shout, Wasa. You know, me, I've not heard here. You know those things. I like it when you come up, you come out like, what's up? Not heard. Or, what did you say? Or maybe you
Hello.
just, yes, sir.
Yes, that swastika symbol is representing errors. Are we able to define the errors, or are we able to define them?
Not really. Yeah, you can't define these errors. In the meantime, this error term has got some assumptions. Okay, this model itself has got assumption. It's said to be blue. Okay, the model itself is said to be blue. To be blue simply means it is supposed to be a best linear and biased estimator. So there are some of the assumptions that underpin this model, okay, that try to make this model valid. So there are some assumptions that we make actually. So if you follow the many writers, they speak about different, they comment on those assumptions. If you follow the Damoda Gujarat 2008 in the book 8th edition, that is the basics of econometrics, the way how he explains the regression analysis, he explains these. He talks about these assumptions. He gives about 10 of them. Okay, if you follow Damoda Gujarat of the Columbia, he gives about 10 of them. Then if you follow these other researchers, such as Abel Bernanke just gives about 5, similar to Grigori Manicure. And so most of the times, depending on how your lecturer wants to present, most of the time they summarize the 10 to just 5 as summarized by Abel Bernanke of Harvard. So basically, there are those assumptions that we really make around these things. Did you get that? Hello?
Yes.
Yes, sir.
Yes. Yeah, so basically, those are just assumptions, of which those assumptions, you will relax them again upward. So it's, yeah, you first begin by studying these assumptions in 1, that's called econometrics 1, then you relax them later on again as you further on in your studies. You relax those assumptions and try to ask. For example, let me give you one of the assumptions that we make. We assume that there is no multicollinearity between these independent variables, right? Multicollinearity simply means that these variables, okay, let me bring this one so that you can easily get it. There is no correlation, okay? Correlation between the independent variables. Correlation simply means the relationship between the independent variables themselves, okay? We talked about the correlation between the independent variable and the dependent variable. Now we're talking about the relationship between those variables themselves. So we assume that they are not related. Why should they not be related? Because if they are related, you won't be able to see which variable is influencing the outcome variable, or by how much does that variable influence that, because they're just related, okay? So we assume that there is non-correlation, like really there's no correlation between the independent variable. But those are just assumptions that you make at early stages of your studies. Then later on you relax them. You say, okay, what if there is There is a correlation now. How do you go about those things? So you learn you learn those things, like how do you go about such things there. Yeah, those are really, really interesting studies. How do you go about when there's white noise regression, or where there's spurious regression? When you have a random walk without drift, what do you do? So they'll give you techniques, okay, on how to go about these things. The techniques that you use. Let's see, how do you use the Pagan Lagrangian multiplier to go about? Anyway, we don't go into such details, but really that's what is there. You got that, right? Don't even panic much. That's what we're just trying to say. Yeah, get it on this surface in the meantime. Clear?
Yes, sir.
Okay, then we can move on. Now that you have known how to extract the coefficients, right? let's further our study and determine now their significance. Let's determine the significance of these variables now. I want to interpret much about, I won't say a lot of things about the standard error, but you can still use the standard error to come up with the t-statistics. You remember the t-statistics under hypothesis testing, right? I want to show you now how we use this in the hypothesis testing. Okay, how we use this same output. Really, like this simple output, you can do a lot. It has got a lot of things that we can do just using this page. There is a lot we can get from this. You remember the t-statistic? We talked about the z-test, the t-test. So with the t-test now, when you have, listen, when you have the t-test like this, you want to find the t-test for, you conduct a t-test for one variable. Let's say for age of years, right? Oh, age of employee, not age of years. Age of employees. You want to find the t-test, right? T-statistics. You just divide by the coefficient for that variable, divided by the standard error. Okay, it will give you the t, the calculated t that you need. Then you compare it with that t you get from the table. This is the calculated t. Just divide coefficient divided by standard error. For example, we have done, we are doing for, what's that? For age, right? I'm just doing one. You say 46 divided by 11, right? The coefficient for this is 46. 46 point what? 933. Divide that by 11.569. What do you get as the t statistic? Anybody?
4.05.
4.05. Yeah, this is the figure that you get. Okay, 4.05. So I've seen that it has already been calculated, like it is here. So those are some of the ways how you use the standard error. You can use it to do the t statistics. Now, what does the t statistics tell you? Okay, we talked about the t statistics. What does it tell you? The t statistics is just used like a z statistics. So at 95 confidence interval, 95 confidence level, right? Let's say at 95. What does it tell us at 95? So at 95, it means the significance level is 0.5, right? It's 5%, 0.05. That's the significance level. That's our output. We did say that, or that's what we are saying right now. If we didn't say it, then that's what we are saying. So this 5% is a significance level. Now, what does the significance level give us? Okay, what does the significance level really give us? It will help us to come up with the t statistics that you get from the table. It's called a t critique. It is called a t critique, just as we said last time in the previous study that we had. That one you get from the table. You compare them. So at 95%, you find that the critique t is what? It was something like 2.131, right? Somewhere around that. Those were, I'm just, yeah. Yeah, it's around this. So what you do, just compare. If you find that this T value is greater than that, you reject the what? The null hypothesis, isn't it? You reject the null hypothesis. That's what he said, that if this critique value is less than this one which you have calculated, the 4.05 is the one that you have calculated. Once if it is greater than this one, you reject the what? The null hypothesis. When you reject the null hypothesis, it means that the variable is what? Is significant. Okay. If you reject the null hypothesis, it means that the variable under concern is statistically significant to the model. In simpler terms, it means that this age of employees matters in this context, okay? It matters. The age of employees matters in what? In influencing the beginning salary. That's how you interpret. It does what? It matters in influencing the beginning salary. We can go to check for which one is it, which again? Let's say for education as well. Education levels, you've seen it's around 10, 9. Whether at 5% or what, it's still big. So you still reject, okay? If you reject it, it means that what? Education level is significant. It sounds opposite, I know. It sounds that opposite. Even us, we were wondering, studying these things those days. Like it sounds opposite. When you reject the null hypothesis, it means that the variable that you have used is statistically significant. But if you fail to reject, it means that the variable is statistically insignificant. Insignificant. So to be insignificant, it means that the variable does not have what? An impact, okay? The variable does not really have an impact. For example, now, let's look at the work experience. Look at the T statistics for work experience, right? Work experience is negative 1 point something. At 5%, is less than that, right? So this one, we fail to do what? We fail to reject. If we fail to reject for this one, it simply means that this work experience is statistically insignificant. That is to say, it doesn't matter. It doesn't contribute to the model, right? It doesn't matter. Yeah, it doesn't matter. I mean, work experience in months. It is expressed in months here, according to the data that we selected. We are just interpreting what we have right now. I know in real life experience, maybe we might say experience will really matter, but most of the times the experience that matters is for years, right? They say 5 years experience, not 1 month experience. Usually they ask about years, right? You know those things. Job category. Job category is significant. It matters to determine the beginning salary, right? You've seen, it is 19. So it's way bigger than the critique value. You reject the null hypothesis, that is to say it is significant. So which simply means that the variable is significant. It has impact to the model. So job category has impact. And this is very true. It is true that the job category has impact. For example, if you start job category as a cleaner, obviously the beginning salary of a cleaner will not be the same as the beginning salary of who? Of maybe a teacher, right? They won't start same. So it just, you know, those things. Yeah. So now, what about these signs? you've seen some variables are negative, others are positive, right? Others are what? Are positive. What does that really mean? Okay. What does that mean? Because the signs, these signs have got meaning. What that means is that, let's start from, which one is which? Let me start from the work experience. It means that what this means is that there is always, it has got a negative impact. Like if you, what should I say? How should I say it? What should be the better term? Because, okay, it means that one increase in what? In one increase in work experience in let's say in months from this model, okay, that they captured, it has got it reduces the total output by about 17 what? 17%. What is the total output that we're trying to look at? Is the salary. Okay, yeah, it sounds contradicting, I know, but we're just following the numbers that we have anyways. Yeah. So those that have got negative effect, it means that they are leading to a reduction, but those that have got a positive, they lead to the increase in every percentage change thereof. Okay, following the questions now, let's do the question that we are asking. Can you state the coefficient of determination and interpolate its value? You know a coefficient of determination? What is the coefficient of determination? It is R squared, isn't it? I said that coefficient of determination is R squared. Aye. So can you state that number? What is R squared in short?
72%.
Yes. What does it mean? Interpret the value. What does it mean?
It's near 1.
Okay. All right. So 72%, which simply means that 72% of variations in what? In beginning salary are influenced by what? By the independent variables. These independent variables that we have listed here. Did you get that? Okay, it's just the same thing that I wrote in the previous, like when I was explaining. So just put it's a template, more like a template. Describe the impact of each factor on the beginning salary. We have talked about the impact, right, of each factor. For example, employee, age of employee, a percentage increase, let's say a percentage change in years of employee will lead to a what? To a 46% change in what? In the beginning salary, which is your Y. So that is to say 1% change in employee years, which means an additional year in age of an employee leads to 46% change in the what? In the beginning salary. Did you get that? Like an additional, which means like this age is changing, right? Your X is changing. So an additional year, okay, in terms of the age of the employee, will lead to a 46% increase. You say increase because this is positive, right? Will lead to a 46%, 46, which is approximately 47% increase in what? In the beginning salary. And of which I think that sounds true, right? Whereby I think if somebody comes as a beginning salary, someone, for example, has got, when they look at the age, someone is 18 years old, they look as if they don't even have a family. then someone comes, they look like family people. These are family men. Obviously, you know those things, they really influence, right? They will say, they might matter. These are just young people, you know, they're being kept. But when they look at that, this one seems to have responsibilities. I don't know if you are getting what you're saying. Hello? Hello?
Hello, sir.
Did you say the interpretation? So you say 1 unit change in X, right? So which means in this, the unit that we are talking about is the age of employees, right? Which means 1 year increase in age, okay? We'll do what? We'll increase the salary by what? By 46% units. The beginning salary will change by that. If you use percentages, you say a percentage increase, that will influence that percentage change. But if you use the units, you can say 1 unit increase in age of employee will lead to 46.9 units increase in what? In the beginning salary. If you want to use percentages, you can say 1% increase in employees will lead to 47% increase in the beginning salary. Did you get that?
Yes, sir.
Okay. Then when you come to education level, you've seen the impact. We are taught to explain the impact of this. Education level, which means 1 year increase in education. An additional year in education will lead to about 3.53 increase or unit increase in total what? In total beginning salary. Which it has got huge impact. It has got a lot of impact. About 3. So there will be that increase, approximately on average, it will be about 353 unit increase. So which means education will really determine like what your beginning salary is. And of which I think you know that this is true, right? You signal to your employers, you give them your papers, your CVs. When they check that this one just has a grade 12 certificate, what happens? If you just have a grade 12 certificate, you know what it means. It has influence. When you have got maybe a diploma, you know what it means. When you are degreed from UNZA or from anywhere, please, when you have a degree, bachelor's degree, let's start from there. Obviously you cannot start the same as someone who has a master's degree, somebody who has a doctorate of philosophy, PhD. A PhD student, like a PhD holder, cannot start like beginning salary same as someone who just has let's say a diploma. That should not really. It is so demotivating, you know those things. You get that? So how to interpret now the words that you use? You to say an additional year in education will lead to what? To 353.34 unit increase in what? In the beginning salary. Did you get that? Yeah, you got it. Yes, you got it. According to this data now, interpreting the data, work experience. So would say a unit change in experience, in work experience, just a unit will lead to a negative 17.14, which is a decrease, will lead to a decrease of about 17.14 units of total what? Total beginning salary. That's the impact. Okay. But I don't know how true this is. on this variable. Anyway, but these are just numbers. Is there any sense in that? Do you drive the sense that when there is a change in the work experience in month, then the beginning salary has to decrease by about 17.14%. Anyway, these are just numbers, but really in an actual saying, I don't think it happens like that in real life. Yeah, obviously it should be the other way around, right? As you increase the work experience, as your work experience is increasing, maybe your beginning salary should be changed, but I don't know about that. I'm not sure about whether the salary should be changed because of you have 2 month experience or what. Yes. I'm just showing you how to interpret the figures in short. Who can interpret on job category? Anybody? I think I've talked too much. Anybody to interpret on job category, what it means, their impact. We are describing the impact of each factor on the beginning salaries.
Can I come in, sir?
Yes, sir.
So on that one, I would say one unit increase in a job category would lead to an increase in the beginning of salary by 1,276.98.
Okay. Yeah. Just that simple, you know. Yeah, you already know this. You have known that. Which factor has the greatest influence on the beginning salary of employees at this parastatal? Justify your answer. So you are examining the impact of these variables. I think I've told you how to examine the impact, right? You look at the T value, okay? Those that have got the greatest T value you get, it means that you reject them, right? Like this, like which one is level of education? The T value is about 10. Job category is about what? 99. Like they are big T values. The T values are bigger when you look at these values. And when the T values are bigger than the critic T value, which is somewhere around 2.13 something, you understand that this simply means that you reject the null hypothesis, right? You reject it. The null hypothesis simply means that they have no impact, right? That's the null hypothesis. Then you reject that, which means they have impact, okay? They have impact. If you reject a null hypothesis, it means that the variable is statistically significant. So all these variables that you have rejected, in short, using the t-test, that same t-statistics we did, right? Using the t-test, those variables that you rejected, they have got greater influence. Did you get that? All of them, eh? Oh,
So what's
maybe
the
someone,
answer?
sorry?
What's the answer there?
We are saying all these that have got the T values that are greater than the alphas, like this, all of them, whether negative or positive. By the way, you know that this direction is balanced. It can go either positive or negative direction. You remember what we said in the previous study. So whether positive or negative, there is some influence, okay? It can either be, the influence can either have some negative effect or it has positive effect. I talked about that. It can be a positive or a negative, okay? You want to get a specific answer. You could pick gender, it has got impact. Job category has got impact. Work experience has no impact. What is that? Educational level has impact. Age of what? Age of employee has what? Has impact. Did you get that?
So
That
the
one
question
was
says,
asking.
which factor has the greatest influence?
Oh, okay. Which factor? Or is one now? So we are looking for one. So these are just factors that have got the influence. But which one has got the highest influence? The one that has got the highest, the one that has got the highest
I
what?
think it's job category.
Job category, right?
Yes.
Hello. My questionnaire. Hello?
Yes, sir.
No, there's someone who was asking about the question. Someone had a question. I don't know if the question is cleared on which one has got the influence, because the T value is determining how much influence is posed into the what's that? Yeah, how much influence that variable has on the outcome.
Hello, sir.
Yes, sir.
Yes, sir. So I think it's a job category, because if you look at the T value for job category, it's higher than that of education level and also the age of employee. That is 9.795. So since
okay.
they're asking for one specific factor, I feel the job category is the correct answer.
Okay. All right. Mr. Questionnaire, are you fine now? I don't know, or maybe there is some other view. Usually when we are explaining, we don't know it all. We are all ready to be corrected all the time. Yeah. Maybe there is some other ideas we reason together. Hello. Is the questionnaire fine?
So in justifying, we say that because it's got a greater T value, or
yeah, it has got the greater T value as compared to this, because we use the T value to make the decision. That's what I would comment.
Okay.
And also, sir, just to add on, if you look at the beginning salary there, I think it's the highest compared to other factors.
Yeah, even the impact you've seen, the impact, it adds about the increase will be about what? 1,277. Really, you know that. Did you get that?
Yes, sir.
Okay. Do not get tired. I know you're tired. You might be tired, but just endure a bit. I want to communicate something on this, because okay, the whole thing is just around interpretation. I think that's where the whole story is. It's just on how to interpret these things. How to interpret, where is that? 44. 44. 144. 44. Okay. You have seen this output again? Yeah, this one is, I've just gotten it from your mod UI. I've just screenshotted this one. I want to try to explain something that I might have not have. If you check there, we don't have the p-value. I want to explain something about the p-value. You can also use the p-value to determine the significance of those variables. This is the t-statistics anyway. For example, this is how you use it now. If this p-value here that you find, this p-value is less than, it is less than what? It is less than alpha. If it is less than, if the p-value is less than alpha, then you do what? You reject the null what? The null hypothesis. Okay? This is the p-value method. Remember last time I talked about the p-value, I said you could also use the p-value to do what? To to test for hypothesis I. So when you look at the p-value, if it is less than alpha, so this time around your alpha, usually the Excel should specify the confidence level, interval level. Usually it is specifies on this part, there should be there website 95. If it's a 95, but most of the times it's around 95. So puts things around 95. So at 95%, your alpha will be what? Will be 0.05, isn't it? Most of the times it's 0.05. So once you find that your p-value is less than 0.05, you reject the what? The null hypothesis, isn't it? Now, when you reject the null hypothesis, it means that what? The variable is significant, is statistically significant, meaning the variable has influence. Right? So for example, look at our p-value for this model. This model. What's our p-value? Is 0.00 something, right? Way less than 0.05, isn't it? So this means that we are rejecting the what? The null hypothesis. What is the null hypothesis? The null hypothesis is saying that price does not have influence, okay? Meaning it's not different from zero. When you say that the variable is not statistically different from zero, it means that it has no impact, okay? So when you check, you look at price. This price, since we reject the null hypothesis, we mean that it now has what? Has got significance. Is statistically significant. Did you get that? So which means the price has influence on what? On the variable that you are looking at. Of which, when you look at this question, for example, this question that is under concern. Let me see the y variable. This, because x is just the x variable. Microsoft Excel. Okay, it was here. It was sales and what? And price. So you know that price influences sales, isn't it? Maybe. According to this, it is significant, meaning it has impact. So price has influence on what? On sales. This was the data. It was regressed using Microsoft Excel. Then this was the output. And these are the variables. The R squared was 87, which was around 88%, which means that 88% of the changes in sales is explained by what? By the changes in price, which is the independent variable. Okay, you can easily get the model. Yeah, you can easily obtain the model from this. Just how we obtain the model. We say, number one, you get the coefficient, okay, the constant variable. This constant is the one that will be the intercept coefficient. It's called the constant, right? Then not just talking, Masa. Right. This is the model. Your model will be sales. Your sales will be determined by constant 644.52, right? Plus this is our beta now. Okay, this is our first B. It will be negative what? Minus 42.6P. Let's say Pi 6P. Okay, this is our model, right? So P up, we'll be just putting a price, a certain price, then you see the changes, right? This is what the model really means. So now, when you check that this is less than 0.05, it means that the variable is significant. So you've seen that using the p-value is very straight, right? Just very straight. Very straight. But most of the times Excel will give you even the p-value. They'll give you the p-value. So sometimes if you don't use the t, you can just use the p-value. The p-value is that very straightforward. Just get the rule of the thumb. It says that if p is less than, if the p-value is less than what? Alpha, which is the significance level, then you reject. If it is greater, you fail to do what? To reject. If you fail to reject, it means that the variable has no influence, right? Or it is statistically insignificant. Did you get that?
Yes, sir.
Okay. Any question? Do you have a question from anyone?
You are clear and tired, sir.
You are clear and tired. And so may the co-host stop recording class.